The camera opens on a hard, wind-bitten ridge in western Alaska, the kind of place where your eyelashes collect frost in seconds, and the ocean doesn't look like water. It looks like metal. Below, the Bering Strait breathes in slow motion, sea smoke rising off dark leads between plates of ice. Far out on the horizon, a thin, gray line of land appears and disappears behind drifting fog. Russia.
I'm standing on the edge of North America. On the Wadis, Russia isn't some abstract place on a map. On a clear day, it's right there. Two superpowers, separated by a strip of ocean and a whole lot of history.
A map graphic slams onto screen. Alaska on the left, Siberia on the right. The narrowest mainland-to-mainland gap is about 55 miles. Not an ocean, not a continent. Just one brutal, shallow throat of water. But the geography hides a trick. Two rocky islands sit almost perfectly in the middle, like stepping stones no one asked for. Little Diomede on the US side, Big Diomede on the Russian side. Between them, the distance is so short it feels like an insult. A couple miles of water, and an international boundary that also slices through time itself. Cut to satellite imagery, then a cinematic tilt down into the strait, currents ripping beneath, ice grinding like teeth. Here's the paradox that makes headlines. If you can see it, if it's only 55 miles, why isn't there already a physical link? Why does this place still feel like the end of the world?
People hear $8 billion link and imagine a neat line drawn across the water. But out here, the water is the easy part. The enemy is everything else: ice, wind, darkness, geology, and the fact that nothing wants you to build anything here.
The documentary shifts into a more surgical tone. Less dream, more blueprint. A CGI cross-section of the Bering Strait reveals the first surprising advantage. It's relatively shallow compared to deep ocean crossings, topping out around a few dozen meters in many areas, which is why the idea keeps coming back. Shallow water whispers possibility. But then the camera overlays the real constraints: seasonal sea ice, moving pack ice, freeze-thaw cycles, storms that can erase weeks of work overnight, and a construction season that feels like it was designed to punish optimism. We cut to archival B-roll, men in face shields, ice crystals clinging to steel. The narrator explains the problem you don't see on glossy concept art. Materials behave differently here. Steel becomes less forgiving. Concrete curing becomes a time bomb. Hydraulics turn sluggish. Electronics lose reliability. And every standard solution from temperate zone engineering becomes a liability.
All right, team, listen up. We need to get this section cleared before the storm hits. Double time it. Keep those heaters running and watch for ice on the equipment. Report any issues to me directly.
Now the story pivots, because the bridge everyone imagines isn't a single structure. It's a system, a chain of problems that must all be solved at once. First, access. There are no major ports right where you'd want them. So the opening act of this mega project isn't pouring concrete. It's creating a temporary civilization. Modular camps, heated hangars, emergency medical rooms, communications towers, runways carved into ice or gravel. On screen, a logistics animation shows ships arriving in narrow weather windows, cargo planes dropping critical parts, and convoys crawling across land that barely qualifies as land. Second, the seabed. Even shallow water can hide unstable sediment, scouring currents, and fault lines. The film leans into sonar visuals, ghostly sweeps mapping the bottom, drill cores rising out of black water. The goal is simple but terrifying. Find bedrock you can trust with towers that will carry loads for a century.
Before you build up, you've got to win the argument with what's underneath you. Because out here, if your foundation shifts by inches, the rest of your structure doesn't adjust. It snaps.
Then comes the engineering fork in the road, the decision that defines everything: bridge, tunnel, or hybrid. A pure bridge faces ice forces and wind exposure. A pure tunnel reduces wind and ice impacts but demands enormous ventilation, fire safety systems, and long approach corridors. Many serious proposals for the region lean toward tunnel concepts because the environment above the water is so aggressive. But the documentary doesn't pick a side yet. It dramatizes the trade. CGI shows a hybrid concept: shorter bridge spans to the Diomedes, then a protected section, either a submerged tunnel or a shielded enclosed deck, designed to survive Arctic wind and ice. The number $8 billion flashes briefly on screen with a subtle warning tag. Headline estimate. The narrator implies what engineers know. The real cost isn't the crossing alone. It's the thousands of kilometers of rail and road infrastructure needed to make the link matter.
Even if you could magically drop the world's toughest structure across this strait, you still need to connect it to the world. That's where costs explode, because this isn't just a bridge. It's a new continent-scale corridor.
Now the build sequence becomes cinematic, but grounded. We see a foundation caisson lowered through a cut channel in sea ice. Underwater robots guide it into position. Piles are driven into rock, and the entire operation pauses whenever wind gusts hit a threshold. Because a swinging load over freezing water isn't dramatic, it's fatal. A tower rises in time-lapse, but not like a city skyscraper. This is slower, heavier, more deliberate. Slip forms climbing while heaters keep concrete within survivable curing temperatures. Steam vents off the structure like a living thing. Sensors appear everywhere. Strain gauges, temperature monitors, accelerometers. A control room watches the tower's movement in real time because in Arctic wind, flexibility is survival.
Everyone thinks strength means rigid. Out here, rigid is how you break. The smarter structure is the one that can move and still come back.
The documentary shifts into luxury and futurism, not as fantasy, but as the emotional reward. Because if this link is ever built, it can't feel like a brutal expedition every time someone crosses it. The inside has to be calm, predictable, controlled. We move through a sleek interior concept, an enclosed corridor where wind noise is muted. LED lighting turns polar night into daylight, and panoramic sections of reinforced glass. The camera glides behind a high-speed rail cabin, silent and pressurized, while freight containers move in the opposite direction like a steady heartbeat.
Think about the experience. Outside, it's chaos. Wind, ice, darkness. You're not just traveling, you're moving through a controlled machine built to ignore the planet's worst mood.
The final act returns to the title's promise, a link between superpowers. Not with speeches, through physical reality. The camera lingers on the symbolism without turning into a history lecture. This isn't about romance. It's about what happens when geography stops being a barrier.
If a corridor like this ever becomes real, it's not just a road, it's a statement. Because once you connect two continents, you don't just change where people go, you change what becomes possible.
The wind returns before the image does. A low Arctic howl rolling across black screen, then headlights slice through drifting snow. We are no longer in the conceptual phase. Now the documentary tightens its focus on execution. To build a fixed link here, the first enemy isn't Russia. It isn't America, it's physics. Sea ice in the Bering Strait doesn't sit politely around your structure. It moves, it stacks, it collides. During winter, massive sheets, meters thick, grind against anything vertical. The force isn't theoretical. Ice pressure can reach levels capable of crushing reinforced marine infrastructure if not properly deflected. That's why any exposed pier in this region cannot be cylindrical in the traditional sense. It must be shaped, angled, like a blade designed to split and redirect ice loads upward instead of absorbing them head-on. A CGI overlay shows the concept in motion. Ice sheets slam into a tapered pier. Instead of building pressure at the base, the sheets ride upward and fracture under their own weight.
You don't fight Arctic ice by overpowering it. You outsmart it. You force it to break itself.
But ice is seasonal. Wind is constant. The Bering Strait acts like a funnel between two massive landmasses. Storm systems accelerate through the gap, producing sustained high winds and sudden gust loads that would terrify even seasoned bridge engineers. This means the structure, bridge, or elevated section must be aerodynamically tuned. Not just strong, stable. Engineers model the entire span in wind tunnels. Thousands of simulations. The documentary slows down here, allowing visuals of digital airflow simulations wrapping around deck sections. Because if wind-induced vibration matches the structure's natural frequency, you don't get a dramatic collapse. You get progressive fatigue, a slow, invisible failure.
The scariest problems in engineering aren't the loud ones. They're the quiet ones. The ones that build stress every second until something gives.
Then comes another layer, seismic uncertainty. The Bering region sits within a tectonically active zone, not the most violent on Earth, but active enough that design codes must assume significant seismic loading over a 100-year lifespan. That means expansion joints measured in meters, not centimeters, bearings that can absorb horizontal displacement, redundancy built into every connection. The film emphasizes the word redundancy, not as a buzzword, but as philosophy. Dual power grids, backup heating systems, parallel ventilation ducts, fire suppression systems capable of functioning in sub-zero airflow. Because if you seal vehicles inside a protected corridor across the Arctic, failure cannot be an option.
Out here, backup systems aren't nice to have. They're survival layers. If one fails, another catches it. And if that fails, a third one stands ready.
Now the camera pulls back to something most headlines ignore: infrastructure gravity. A crossing alone changes nothing. On the Alaskan side, road networks thin dramatically as you move west. On the Siberian side, vast stretches remain sparsely developed. For a true continental corridor, road and rail, thousands of additional miles would need upgrading or building. Freight terminals, customs facilities, maintenance hubs, energy supply chains. The documentary overlays a glowing trade map. Europe to North America by rail, East Asia to continental US without ocean shipping. The geopolitical implications are massive, but so are the logistical ones.
This isn't just about saving time on a flight. It's about rerouting supply chains. It's about reshaping how goods move between continents.
The number returns $8 billion. The narrator pauses on it. Because here's the truth: depending on design, length, supporting infrastructure, and political conditions, realistic estimates could climb far beyond that headline figure. Some long-standing conceptual proposals have ranged dramatically higher when full rail integration is included. So why does the idea refuse to die? Because geography keeps whispering, it's only 55 miles. Because the Diomede Islands sit there like punctuation marks in the ocean. Because human history has repeatedly shown that when engineering meets ambition, barriers fall. Eventually, the documentary shifts tone again. Less technical, more reflective. We see night over the strait. Aurora Borealis flickers above frozen water. A digital rendering fades in, an illuminated corridor stretching across the dark like a spinal cord of light between continents.
For thousands of years, this was a migration route. Then it became a boundary. Imagine if it became a connection again.
A hypothetical first crossing sequence plays, not triumphant, but measured. A convoy of electric freight vehicles gliding through a climate-controlled tube. A high-speed rail train passing beneath in a separate deck. Sensor readouts streaming in a control center staffed by engineers from both sides. The symbolism is subtle but clear. 2 control rooms, 2 languages, 1 structure.
When you build something at this scale, you don't just solve engineering problems. You create shared responsibility, shared maintenance, shared risk.
The camera returns to the anchor standing near the icy shoreline where we began. Daylight now, the sea still shifting, indifferent. He kneels, picks up a fragment of wind-polished ice, and lets it fall back to the ground.
This place doesn't care about politics. It doesn't care about budgets. It doesn't care about ambition. If this link ever becomes real, it will be because engineers figured out how to work with nature, not against it. The final sequence intercuts 3 timelines: indigenous migration across ancient land bridges, Cold War footage of tension across the strait, a speculative future convoy moving smoothly across a controlled corridor.
No narration for several seconds, just wind.
55 miles. That's all that separates 2 continents here. The question isn't whether it's possible. The question is whether we're ready to build something that powerful. The Bering Strait remains one of the most ambitious proposed infrastructure crossings in modern history. Don't miss what's coming next. Subscribe and stay informed.